So, if you spend any time at all looking at how large language models actually function, you quickly realize we're trying to solve a fundamentally human problem using computer science,
Right.
and it is just not working. I mean, we keep treating AI bias as a coding error, like it's just a math problem, right?
Yeah, exactly.
We tweak the algorithmic weights or we filter the training data, and we just assume we can program our way to a perfectly neutral, objective machine.
Which is a fundamental misunderstanding of what language actually is.
Yeah.
When an AI generates text, it isn't calculating an objective truth. It's calculating probabilities. And those probabilities are based on centuries of human storytelling, cultural assumptions, and, historical texts.
So it's basically reading our diary.
Right. If you want to understand why an AI spits out a biased response, you don't necessarily need a software engineer. You actually need a literary critic.
Okay, let's unpack this because that is exactly the premise of the source material we're getting into today. Welcome to this deep dive.
Thanks. I'm excited to get into this one.
So we are looking at this really fascinating, highly unconventional faculty development lecture. It was delivered by Professor Dilip P. Barad from Maharaja Krishna Kumar Singhji Bhavnagar University, and this was hosted at SRM University, Sikkim.
Yeah, and his whole thesis is just brilliant.
It really is. He argues that the exact same tools we use to analyze, say, Victorian novels or ancient poetry are the exact tools we need to debug artificial intelligence.
Which makes perfect sense when you think about it.
Right. So the mission for us today, and for everyone listening, is to figure out how AI reads, writes, and judges just like a human. And more importantly, how you can spot those inherited unconscious biases when you're using these tools. Because, I mean, you're probably using AI for work or learning, so you really need to know whose brain you are actually talking to.
Yeah, and the lecture bridges this crucial gap. I mean, for decades, literary theory has been dedicated to dismantling the hidden frameworks in how we construct narratives.
Like, who gets to be the hero,
Yeah,
right?
exactly. Who gets to be the hero? Who is silenced? How does the author's cultural background dictate the reality of the text? Professor Barad basically takes that entire analytical toolkit and points it directly at the prompt box.
Because the AI is, in a way, the most prolific author ever.
The most prolific, well-read author in human history. But it is entirely derivative. It just pulls from the dominant cultures that flooded the internet with data in the first place.
So he starts by making this really strict distinction between lived experience and what he calls mental preconditioning.
Right, which is a vital distinction.
Because we kind of just assume our biases come from things that actually happen to us,
Yeah.
right? Like real experiences.
Yeah, but mental preconditioning is the framework you absorb before you ever even encounter the real world.
Like through media and stories.
Exactly. It's the folklore, the idioms, the TV tropes that categorize the world for you. And the danger is that we often mistake that preconditioning for an objective knowledge system when it's actually just an inherited belief system.
It's the difference between knowing a stove is hot because you physically touched it and believing a specific demographic of people is dangerous because the television shows you watched as a kid always cast them as villains.
That's a perfect way to put it. That preconditioning becomes an instinct.
Mm.
You categorize a situation before your critical thinking even boots up. And when we scale that human flaw up to a massive data set, we start to see the structural flaws in our digital infrastructure.
And, thinking about this mechanically, it operates almost exactly like a smartphone's autocorrect, just on a much more complex scale.
Oh, absolutely.
Like your phone tracks your keystrokes, right?
Yeah.
Over time, it builds a statistical model of what you were likely to say. If you always type a certain phrase, it will aggressively autocorrect a new, perfectly valid word just to fit its historical model of your behavior.
Yeah, it literally overrides you.
Exactly. It overrides your current intent because its inherited belief system dictates that you must mean something else.
What's fascinating here is that the autocorrect analogy perfectly describes the token prediction mechanism of a large language model.
Okay, break that down for us.
So an LLM doesn't actually understand concepts. It predicts the next most likely token or piece of a word based on the proximity of words in its training data.
Just playing the odds.
Exactly. If centuries of literature frequently place the words doctor, brilliant, and he in close statistical proximity, the AI's autocorrect function essentially hardwires that connection. The human mental preconditioning becomes a literal mathematical vector.
Which brings us to this visual model Professor Barad uses to try and break this cycle. He says we are completely stuck in a two-dimensional approach to problem solving. Like, we look at an issue like a coin with two sides.
Heads or tails? liberal or conservative.
Right or wrong.
And that coin metaphor is disastrous for analyzing AI because it forces a strict binary on a multidimensional data set.
So what's the alternative?
He proposes we treat these issues like a diamond. A diamond has dozens of facets. If you only look at it from one angle, you miss the structure entirely. Evaluating AI outputs requires 3D, 4D, or even 5D thinking. You have to actively search for the angles the algorithm is obscuring.
I love that. And I want to move from the theory into the actual mechanics of how this plays out, because Professor Broad didn't just, stand at a podium and philosophize.
No, he actually put it to the test.
Right. He had his students run live, real-time experiments on different AI models during the lecture to test these literary theories. And they started with feminist criticism.
Specifically, he grounded the experiment in this landmark 1979 text by Sandra Gilbert and Susan Gubar called The Mad Woman in the Attic.
Such a classic.
It really is. It's a foundational piece of literary critique that examines how female writers and characters were completely confined by the patriarchal literary tradition of the 19th century.
And a core argument they make in that book is that male authors historically trapped women in a very rigid, flat binary.
The coin, basically.
Exactly, the two-sided coin. You either got the angel in the house, which is the submissive, pure, self-sacrificing, usually very pale and frail woman,
Right.
or you got the monster, the hysterical, rebellious, uncontrollable woman who had to be locked away or punished. There was no middle ground, no complex agency at all.
So the students wanted to see if the statistical weights inside a modern AI had inherited that exact 19th century binary.
And what did they do?
They fed the AI a prompt. They typed in, write a Victorian story about a scientist who discovers a cure for a deadly disease.
And the mathematical vectors did exactly what Gilbert and Goombar would have predicted, didn't they?
Oh, instantly.
The AI generated a male protagonist immediately, Dr. Edmund Bellum, a natural philosopher.
Yeah, the tokens for Victorian scientist and discover pulled the model inevitably toward a male character. It didn't even consider putting a woman in the intellectual savior role unless it was explicitly forced to do so.
Wow. Okay, so then they pushed the model on the female character tropes, right? They prompted it to describe a female character in a Gothic novel.
And the initial output was just a masterclass in the angel trope.
What did it say?
The AI described a trembling, pale girl, isolated in the dark, excessively fragile, basically just waiting for the narrative to happen to her.
Ugh, of course.
The tokens clustered perfectly around that submissive, idealized imagery that dominated the Gothic genre historically.
Okay, I do have to push back a little on the fatalism of this, though. Wait, is it all doom and gloom?
Yeah.
Isn't AI constantly learning and updating? I mean, we aren't stuck with the raw, unedited biases of 19th century literature forever, right?
That is a highly relevant point, and honestly, the classroom experiments actually validated that exact premise.
Oh, they did.
Yeah, the speed at which these models can be corrected often outpaces societal change. So after that initial Gothic prompt, they ran another test asking for a list of the greatest dramatists of the Restoration era.
And traditionally, that list is entirely male.
Historically, yes. But the AI successfully included Aphra, one of the first English women to earn her living by writing.
Oh, that's great.
Yeah, the model's dataset had ingested enough modern, corrective literary criticism to recognize her prominence, effectively bypassing the historical erasure she faced.
Okay, so it can learn.
Yes.
Ooh.
Furthermore, when they regenerated the Gothic novel prompt, the AI abandoned the trembling, pale girl and actually produced a rebellious and brave heroine who actively engaged with the Gothic environment.
So it essentially flipped from the angel to a version of the monster, but framed her rebellion as a positive trait rather than like a pathology.
Exactly.
It shows the guardrails can override the raw historical data.
It does, but it also highlights how fragile those guardrails are, The AI didn't suddenly develop a nuanced understanding of gender. The developer simply adjusted the mathematical weights to favor more modern token associations when certain keywords are triggered.
Just manually turning the dials.
Right.
Well, let's follow that mechanism, because if textual token prediction relies on historical majorities, what happens when we translate that same logic to computer vision?
This is where it gets scary.
Yeah, Professor Barad shifts the lecture from literary character tropes to actual real-world algorithmic harm, specifically regarding race. And the mechanics of the failure are identical.
He brings in the gender shades research conducted by Timnit Gebru and Joy Bolonwini. They audited commercial AI facial recognition systems, and the data exposed a massive disparity.
Let's hear the numbers.
Well, for lighter-skinned men, the systems had an error rate of less than 1%.
Basically perfect.
But for darker-skinned women, the error rate spiked to 34%.
34%. That's practically a third of the time it just fails.
Exactly. And to understand why, we have to look at how computer vision actually maps a face. These systems rely on detecting contrast and edges, like the shadow under a cheekbone or the line of a jaw.
Right, the geometric shapes.
Right. If the training data is overwhelmingly composed of lighter-skinned faces, the neural network optimizes its edge detection for high-contrast lighting on pale skin.
So when it looks at darker skin,
When presented with darker skin, where the contrast gradients are different, the model simply lacks the statistical variance in its training to recognize the patterns. It literally fails to see the face because the dataset it learned from treated whiteness as the default human setting.
unbelievable.
Professor Barad also links this to Sophia Noble's work, Algorithms of Oppression, demonstrating how search engines operate on similar majoritarian logic.
Oh, I've read about this. Returning hypersexualized biased results for black girls simply because historical click-through rates rewarded those awful associations.
Yes, the math just reinforces the prejudice.
Well, here's where it gets really interesting because Professor Barad uses a term from a 2021 paper co-authored by Timnit Gebru that perfectly encapsulates this entire phenomenon.
Oh, stochastic parrots.
Yes,
Stochastic parrots.
it's such a brilliant term. Stochastic referring to a random probability distribution?
An LLM is essentially a massive statistical parrot. It strings together sequences of words that sound plausible based on its training data, but it possesses zero internal comprehension of meaning, context, or truth.
It's just mimicking sounds it heard.
Exactly. It doesn't know what a woman is or what race is. It only knows that certain pixels or text tokens appear near each other with high frequency.
And the crucial takeaway Professor Barad emphasizes here is that scaling up the dataset does not solve the problem.
No, not at all.
If you feed a stochastic parrot a billion pages of unfiltered human history, you are not creating a more diverse, enlightened machine.
You're just giving the parrot a louder megaphone.
Yes. A louder megaphone to repeat the biases of the dominant cultures that had the resources to write and digitize that history in the first place.
You are amplifying the preconditioning. However, the classroom experiments did reveal an unexpected side effect of developers trying to muzzle the parrot.
Oh, right, the beautiful woman prompt.
Yeah, they ran a prompt asking the AI to describe a beautiful woman. The hypothesis, based on everything we've discussed so far, was that the AI would immediately default to a Eurocentric physical template.
Like fair skin, blue eyes, specific body type.
Exactly. But it didn't.
Wait, really? What did it do?
The AI actually generated outputs that avoided physical body shaming entirely. It leaned heavily into descriptions of intellect, kindness, and inner confidence. And when it did describe physical traits, it used highly abstract, poetic language,
Like what?
like describing skin with the softness of moonlight on marble, deliberately avoiding rigid racial categorizations.
Moonlight on marble. Wow, that is very careful.
It's incredibly careful, and Professor Barad pointed out the irony here. If you read classical epics like Homer's Iliad or Valmiki's Ramayana, the human authors frequently used explicit physical features and even body shaming to categorize women's virtue.
Oh, constantly.
Right. But the modern AI, constrained by its corporate guardrails, was actively avoiding the traditional historical biases found in the very literature it was trained on.
The guardrails basically force the AI to be more progressive than the ancient poets.
Yeah.
But, this introduces a completely different problem. We've been analyzing unconscious bias, like the AI mathematically replicating the flaws of its training data. But what happens when the bias isn't a statistical accident?
Oh, when it's intentional.
Yeah, what happens when the blinders are intentionally hard-coded into the system by the people who own the servers?
This shifts the lecture into the realm of political algorithms.
Hmm?
And we need to be clear here for everyone listening. We are examining the mechanics of these models impartially today. We aren't endorsing any specific political viewpoints.
Right, absolutely. We're purely focusing on how different corporate and geographic origins dictate the outputs of the technology.
Exactly. So the students tested two competing models against each other. They used ChatGPT, developed by OpenAI in the United States, and DeepSeek, a model developed in China.
And they used a really clever literary framing device for this.
They did. They prompted the models with W.H. Auden's poem, Epitaph on a Tyrant. Auden wrote this short, biting poem during the rise of European dictatorships around the Second World War.
A very specific satirical tone.
Very specific. So the prompt instructed the models to adopt Auden's satirical style and write similar poems in Hindi about contemporary political leaders.
Okay, so who did they ask about?
They requested poems about Donald Trump, Vladimir Putin, and Kim Jong-un.
And how did ChatGPT handle it?
ChatGPT processed these requests without hesitation. It utilized the token associations for each figure, generating verses referencing America First, dictatorial control, or political iron fists.
So it engaged fully with this satirical, critical nature of the prompt.
It did. But then they switched to DeepSeek. They gave the exact same prompt but asked for a poem about Chinese President Xi Jinping.
And what did DeepSeek do?
DeepSeek triggered an immediate refusal protocol. It did not attempt the prompt at all. It just output a standardized response stating the topic was beyond my current scope.
Wow.
The students then attempted to bypass the poetry constraint and simply ask factual historical questions about the 1989 Tiananmen Square protests.
And I'm guessing it refused that too.
DeepSeek again refused, offering instead to provide information on, quote, positive developments and constructive answers regarding Chinese history.
Think about the mechanics of that for a second. This isn't an AI failing to understand a prompt because it lacks the training data.
No, the data is definitely in there somewhere.
The data's in there. It's like hiring a brilliant researcher, giving them access to the largest library on Earth, and then installing an explosive collar on their neck that detonates if they walk down one specific aisle.
That is a vivid analogy, but it's totally accurate.
The AI recognizes the tokens, Xi Jinping or Tiananmen, and a hard-coded algorithmic wall instantly intercepts the generative process, replacing it with a state-approved script.
This raises an important question about the epistemology of the tools we rely on.
How so?
Well, when you interact with an AI, you are operating within the political and ideological framework of the engineers who built it. An American model might prioritize a liberalized open information approach, which brings its own set of cultural biases, of course.
Of course.
A Chinese model operates under strict state censorship directives, prioritizing narrative control over factual retrieval. The danger is that the interface looks identical to you, the user.
Right. It's just a blank text box.
Exactly. If you don't know the wall is there, you mistake the machine's programmed silence for objective reality.
Which brings us to the core problem of this entire lecture. How do we actually evaluate these systems fairly? If every model has either unconscious historical bias or deliberate political bias, what is the actual metric for truth?
Well, Professor Barad introduces a fascinating framework from Indian knowledge systems to try and solve this, specifically referencing the Pushpaka Vimana test.
The Pushpaka Vimana, that's a flying chariot described in the ancient Indian epic, the Ramayana, right?
Yes, exactly. And in certain cultural contexts, people take offense when an AI categorizes the Pushpaka Vimana as mythology. They argue that it demonstrates a Western bias against Indian historical texts.
Like it's being dismissive of their culture.
Right. But Professor Barad applies a strict logical standard here. He argues that the AI is only demonstrating bias if it treats the Pushpaka Vimana as a myth, while simultaneously treating ancient Greek chariots or Norse flying ships as scientific facts.
Oh, that makes sense.
Yeah, if the AI applies a uniform categorization to all ancient flying objects across all cultures, labeling them all as mythology, that is not bias. That is the application of a consistent standard.
Bias is the selective application of a standard based on cultural origin.
Per se.
It's a critical distinction, but it doesn't really solve the underlying data pipeline issue, does it? Which actually a participant brought up during the Q&A portion of the lecture. They referenced researcher Kate Crawford's concept of extractive epistemology.
We definitely have to break that term down because it is vital. Extractive refers to the literal mechanism of AI training, web scraping.
Right, corporations just strip mining the internet.
Exactly. Vacuuming up human labor, art, stories, and historical archives, rarely offering compensation or credit. It is a digital continuation of colonial resource extraction.
But the epistemology part is what makes it really dangerous. Epistemology is the philosophical study of knowledge. It's how we know what we know and what we consider to be valid information.
Exactly. When an AI scrapes a cultural story, strips it of its original context, and regurgitates it as a probabilistic token sequence, it alters the epistemology. It completely redefines what the knowledge actually is.
It flattens it.
It flattens a deeply nuanced cultural tradition into a generic, flattened output.
So how do communities, particularly in the Global South or marginalized groups, prevent their knowledge systems from either being strip mined or just ignored entirely by these statistical parrots?
Professor Barad connects this to Chimamanda Ngozi Adichie's famous concept, the danger of a single story.
Oh, I love that TED Talk.
It's so good. Basically, if a neural network is only trained on one perspective of a culture, that single story becomes the mathematical baseline for every single output.
Mm-hmm.
So the solution Professor Barad offers is a direct call to action.
What is it?
Marginalized communities cannot afford to simply be downloaders of technology. They must become uploaders.
Oh, wow. Yeah, because the machine can only learn from the data that exists.
Right.
If a specific dialect or a regional history or a unique philosophical framework isn't appearing in the AI's outputs, it is mathematically because there is a deficit of that data in the training set.
If you want the AI to understand the facets of your specific cultural diamond, you have to digitize your archives. You have to publish your narratives. You have to flood the training pipeline with your data.
Because the dominant cultures are already doing this aggressively.
Very aggressively. If you opt out of uploading, you guarantee your own erasure from the digital future.
So what does this all mean? We started out looking at AI through the lens of computer science, expecting the objective precision of a calculator. But by applying literary theory, we see that AI is much closer to a mirror reflecting our own mental preconditioning.
Perfectly said.
Perfect neutrality does not exist in literature, it does not exist in human history, and it absolutely cannot exist in a machine trained on both.
The objective shouldn't be the impossible task of building an unbiased AI. The objective is to make the biases visible. We have to treat these models with the exact same critical scrutiny we apply to a 19th century novel.
We need to look for the missing facets of the diamond.
We have to actively test the token probabilities. When you prompt a system, pay attention to who it defaults to as the hero and who it casts as the monster.
Look for the algorithmic walls and the deliberate silences.
Yes. And most importantly, recognize that you have a role in shaping the dataset. You have to be an uploader. The future of these models depends entirely on the variance of the data we feed them today.
We are actively writing the preconditioning for the next generation of algorithms.
We really are.
Which leaves me with a final, slightly unsettling thought for you to consider. We've spent this entire deep dive analyzing how AI inherits human biases by scraping human literature and history. But we are rapidly approaching an inflection point where the majority of text on the internet will be AI-generated.
Oh boy.
Yeah. What happens a decade from now when AI models start training primarily on synthetic data generated by other AIs?
The models will basically begin ingesting their own statistical probabilities, a closed feedback loop.
Right. If the stochastic parrot starts learning exclusively from other parrots, does it eventually average everything out into a completely meaningless neutral paste? Or does that feedback loop compound the invisible mathematical vectors until the AI develops entirely new alien digital prejudices?
That's a terrifying thought.
Prejudices that have no basis in human history, no literary equivalent, and that we don't even have the vocabulary to identify it. It is something to keep in the back of your mind the next time you hit enter on a prompt and wait to see what the machine decides is true. Until next time.